Now students, let us try to understand this concept and the formulas like in a more better manner by using two simulations where we can easily in real time change the mass and the distance of the objects, and accordingly you will see how the gravitational force is increasing, right? Let us go to the simulation. Okay, so here we have two planets or two huge masses with us. Okay, object A and object B. Object A is the maroon one, which is on the right hand side, and object B is the green one on the left hand side. So here we have to move the planets to see the influence of their position on the gravitational force. Okay, let us move the planets away from each other. Here you can see. Okay, as I'm moving the planets away from each other, okay, their mass is constant, right? Their mass is constant, you can see both of them, their mass is constant, the size is constant, the size is proportional to mass, you can say. Okay, at least for here. As I'm bringing them closer and closer and closer to each other, you can see the gravitational force is increasing too much. The arrow mark, the size of the arrow mark is denoting the amount or the magnitude of the gravitational force, right? So as I'm making them go far away from each other, you can see the gravitational force is decreasing constantly. As I'm bringing them closer and closer and closer and closer to each other, the gravitational force is increasing, right? So this is what happens if we change the distance. The more the distance, the less the gravitational force. Remember, inversely proportional, okay, divided by r square in the formula, remember. But what if I change the size, or you can say the mass? Here the size is proportional to mass, at least for this simulation, right? You can see as I'm increasing the size, the gravitational force is increasing. If I decrease the size more and more and more and more and more and more, okay, if I am decreasing the size, just a moment, okay, if I am decreasing the size here also, alright, here you can see if I am increasing the size, the magnitude of the gravitational force is increasing. If I decrease the size, if I make it smaller and smaller and smaller and smaller and smaller and smaller, very small, you can see the gravitational force is decreasing. Now, can we change do the same thing for the other object also? Same result we'll get. See, if I change the size of the other object also, the gravitational force is decreasing. If I increase the size of the mass of the green object also, the gravitational force is increasing, right? Same thing happens if I change the distance of the left hand side object also. If I increase the distance between them, the gravitational force is decreasing. If I make them closer to each other, that means if I am decreasing the distance in between them, then the gravitational force is going to increase. Okay, so I hope students you got a very good idea regarding how it happens in reality, right? Now let us go to our next simulation, which is going to be simulating laws of gravitation. Okay, all right, so here we have the universal law of gravitation. You can easily see the formula here. Gravitational force is given by capital G, capital M, small m. Capital M, small m means they are denoting the two masses of the objects, right? And D, small d, it is denoting the distance in between them, correct? So here we have an interactive simulation where we can increase or decrease the masses of the object. We can also increase and decrease the distance between the objects, and in real time we will be able to see the changes in the gravitational force in the formula. It is going to change. Now suppose if I make the small m, if I increase the size or the mass of small m to 9 or 100, okay, and I also change the capital M to, let's say, 200. Okay, here you can see previously the gravitational force was different, now it is 204.06 g. G here, the value they have not put to simplify our process. Okay, if you put the value of g here, obviously the value will change, the end gravitational force result will change. So since g is a constant here, so it will not affect the simulation. Got it? Now what if we change the distance in between them? Now right now the value is 204.06. See, if I change the distance in between them, see how the gravitational force is also decreasing. If I am increasing the distance, see, increase distance, decrease in gravitational force. Okay, If I decrease the distance, make them closer and closer to each other, if I decrease the distance, you can see the gravitational force is increasing, right? If I bring them closer and closer to each other, correct? So the value of mass increases as it is written here. You can see force increases, gravitational force increases. When the value of D increases, F decreases, because they are inversely proportional to each other. As you can see here, students, they are inversely proportional. F is equal to capital G multiplication of both the masses divided by D square. Got it? So from this simulation, I hope everyone is clear with the formula of universal law of gravity.